I can tell by how blank most of our whiteboards are that we're a bit confused. So, pause. I'm going to go ahead and down here, I'm going to be finding the product A times B. As Joe, my helpful volunteer, is going to, one at a time, cross down. And then when I tell him, cross over down. Then he's going to go to the next row, cross down. And then when I tell him, cross over down. And then the last row, cross down. And when I tell him to, cross over down. Some of you might want to be looking at your examples. You guys have this in the back of your homework spiral written down. So you might want to go ahead and see if you can follow what we're doing. But I want you guys to, as Joe points and as you maybe try to follow, whatever he's pointing to, what operation do we do as you point? Multiply. And then when we switch, what operation? Add. So we're going to cross and down, multiplying as he's pointing, and then adding. Ready, Joe? First row, first column. Point. You guys, call out. What do you see?
0.
Switch, Joe. Which means add. What do you see?
-4.
Switch. What do you see?
2.
Okay. Go ahead and move back, Joe. So, if you're good at mental math, you could write this out, or you could say 0 minus 4 plus 2. What's 0 minus 4? -4. Plus 2 is -2. So the answer in this product is going to have AB as the first entry, -2. Now, hold on, pause. Why am I even solving this problem? How do I even know it was legal? Was Joe able to match up the cross with the down as he was going? Did it match up as far as the order or the dimension? Yes, because the number of columns equals the number of rows. My people that were trying to figure out if it was legal or not, what are you supposed to be comparing? The insides, and do they match? Yes. If you can go across and down corresponding entries, it's legal. It's legal. Any questions as to how the -2 came about? You sure? So one more time. Joe, go ahead and point the first row, first column one more time. What do you guys see? 0 plus -4 plus ends up equaling -2. Cool? But how many more things do we still have to fill in? When these two match, what size answer are we trying to get? The order of the result is a 3 by 2, which means we're trying to fill in, technically, if I was to make the size of the matrix, this is what we're trying to fill in as our answer, right? So what have we done so far? First row, first column. Why? Because he went across the first row and down the first column. But now I need the first row, second column. So what is Joe going to do when I say cross over down? What row is he going to start on with his left hand? No. Why is he still in the first row? Because I'm finishing my first row. Oh, is that okay? So he's going to start back on the first row again, but the first column, first row. And then where is he going to start over here? Second column. All right, Joe, go ahead and point. What do you guys see? 0. Switch. What do you see?
5.
Switch. What do you see? So, check mental mathers. 0 plus 5 plus 12, isn't that 17?
Yeah.
Now, how do we go to the second row answers? Start at the second row. All right, Joe, go to the second row. But he's going to start back at the first column. Why? Because we want the second row, first column entry. So what do you guys see? Switch. Switch. All right, Joe, go ahead and grab a seat. Do we have an idea? Go back to your groups and try to finish on the whiteboards. And then once everybody's in agreement, go to your homework spirals. Once everyone's in agreement. Now, someone should probably do the multiplication in the calculator to make sure that we're good. Or to make sure you're good once you finish. But let's try again. Let's try again. 12 plus 3, right? 12 plus 0 plus 3? Make sure to check back in with your group. Some of you are trying it on your own, that's good. But then check back in and remember, get it on your calculator. You can be checking if you're right at the end. Yeah, go ahead and collaborate. Double check.
48.
You guys can check the next one. It should be 12. Bottom row, did you guys get 18 for the first?
Yes. Nice.
How about 46?
Yeah.
Now, whoever ended up writing on the whiteboard for this problem, I want you to go ahead and erase the whiteboard and switch. Because now I'm going to give you a new problem. I want you guys to write it in your homework spirals, pencils down, and then all three heads working together, but only one person with the marker, and it can't be the same person who had the marker on this problem. I want you guys to try to find for me A times B. Go. Erase the whiteboard, someone new with the marker, write it in your homework spirals, the problem, and then pencils down. I want discussion this time. I want someone new with the marker, A times B. But once the problem is written down, pause. You'll have time in a second to do it on your own. But I want you guys to be discussing, talking through, step by step, someone new with the marker, but all of you discussing. You can be pointing if you're not having the marker, that's totally fine. All right, pencils down. You guys should have the problems written by now. Here we go. All heads turn together. Everyone can see the whiteboard. Everyone talking it out, checking the steps, etc. You might be telling them what to do, or they might be trying it and you're agreeing or disagreeing. Go. Wait, pause. Is it legal?
Yeah.
Why?
Because the insides are the same.
It's a 3 by 2 and a 2 by 2?
Yeah.
What size is the answer? So do you know what you're trying to fill in? All right, good. It is legal. Go.
down. No, you go down. You go down. Oh, never mind. I'm behind you guys.
Pencil down. You guys good? You all agree? Okay, then go ahead and solve it out in your notes. I was making sure you all agree first. So get it in your homework spirals. Did you guys check it in your calculator? Cool. There's going to be one more problem, so the last person is going to get the whiteboard marker. If you guys had checked it in your calculator and you agree, you all agree, the calculator agrees, then everybody get it in their homework spiral. Once everyone agrees. If any group gets stuck or any person gets stuck, reach out to me. But there's one more problem, so the last person who hasn't done a full problem on the whiteboard, it's your turn next. How'd I do? Because Tyler, it's second row for this guy, second column. So second row, second column, -4 and 0. You see it? There you go. Okay. If your groups are good, everyone's on the same page, all of you have it written down in your homework spiral. Go ahead and erase the whiteboard, last one. Go ahead and erase the whiteboard, last one. So go ahead and pass the whiteboard to the third person who hasn't done the whole problem on the whiteboard. Last multiplication. All right, write down the problem. Last one. Write it down in your homework spiral and then pencils down. Talk it out one last time. At this point, hopefully, though, we've mastered it. But talk it through. And once everyone agrees, then you can write it down. All right, once you have it written, pencils down, talking it out. Use your mouths. One person, the last person has the marker. Is it legal? Yeah, it is. But the answer is going to be a little different size, right? Is somebody doing it in the calculator, double checking? All right, collaborate with the person with the whiteboard. Are they getting it? Do you understand what they're doing? So, question. Who can raise a hand and tell me where the -5 came from? Walk me through, step by step.
Plus 0 minus 3.
-2 plus 0 plus 3, but -3. Jason, where'd those numbers come from?
From the top row, from the first row, first column.
Nice.
And you switch.
And then you. So -2, 0, -3. Who can fill in for me what this number should be? 7? Okay, so Salma, walk me through. How 7? Good. Uh-oh. Okay, first row. You're okay. Yeah, because first row, second column, right? So 4, 0, 3? Good, got it. So 4, 0, 3. Okay, what number should go here? Okay, Tyler's walking me out. Second row, first column. So what do we get? So -4, -1, +2 should end up, anybody getting 3? Ooh, -3? Good. What's the last number that I'm missing?
6.
6? Sam, how do I get it? Second row. Which column? Got it. And so what do you see? You got it. 8, 0, -2. Booyah. How are we doing? So cross down, does it make a little more sense now? Cross over down, does it make a little more sense now? And then, once you cross down and then cross over down, what is it time to do? Switch the rows, right? Cross down, cross over down. Dun, 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 dun. Cool. Notes, let's go. Notes. Little baby whiteboards. Go ahead and erase them. Whoever got it, go ahead and return it to where you found from. Throw the markers back in the cup and throw away the tissues. Go ahead and do that. People who got them, go ahead and return them. Whiteboards erased, tissues thrown away, markers returned to their cups. All right. This was the example that was technically supposed to go into our notes. You guys already have it in the back of your homework spiral, so I'm not going to have you write it again. However, my question to you is, we actually didn't finish this problem. We actually didn't finish this problem. The ending of this problem is actually way down here where it says not only find A times B and state the order of the result. The order was a 3 by 2. Here is that said 3 by 2. But it also said find B times A. So my question is, now that we've really worked on matrix multiplication, the trickiest part of section 8.2, what would you guys say to me saying multiply B times A? Why impossible? You could either write B first, that's one way of thinking about it, and you could actually say, okay, here's 2, here's -1, here's 4, here's -5, here's 1, here's 6. And then you could write A, and you could have your 0, negative 1, 2, 6, 0, 3, 7, negative 1, 8. And you could say like, oh yeah, I'm totally doing what you want me to do. There's my B, there's my A, and then you start and you say, cross down. What's wrong?
Nothing's there.
So you could just start trying to do the multiplication, and nothing's there when I go to do the third row, third column. What else could I have done? Couldn't I have thought of this guy being a 3 by 2? And thought of that guy being a 3 by 3? How could the orders tell me to stop and not even try? The inner don't match. So you could actually start multiplying, but if you are left hanging somewhere, it's impossible. But the orders also tell you, the insides don't match, so forget that. Does that make sense? The insides don't match, so forget that. Therefore, the answer would be impossible. And as we saw yesterday, wasn't there something like dimension mismatch or something like that, right? Something about dimension not being the right size. So some multiplications, just a quick reminder, are illegal, even though we did legal ones to practice. Guys, what if they give you something like find a squared? Oh, 941, done. No. Joe, how do I do a squared?
You use a times a.
Oh, a times a. Okay, that's easy. So 941. Why would your calculator say dimension mismatch? Matrix multiplication. I have to go across and there's nothing there. I have a 1 by 3 and sorry, just kidding. I have a 1 by 3 and a 1 by 3. Doesn't match. My cross down doesn't work. Do you think maybe there's a way to kill a puppy with matrices too? Binomials, is it really hard sometimes to think about what something like x plus 2 squared would equal? Because you're like, x squared plus 4. Wrong. Because you're supposed to FOIL. Matrices, same thing. 941, wrong. Because you're supposed to multiply the matrices in a legal way, which is impossible. So in this case, a squared does not exist. What size would a squared, well, would a have had to have been such that I could square it? 1 by 1. But a 3 by 1 and a 3 by 1 actually still wouldn't work because I couldn't go across and down. If they're both the same, we would need what we would call a square matrix, because only a square matrix would have the same number of columns as rows. Joe, go ahead.
I mean, like for this problem, can you add a row or column 0 to the matrix?
No. Because the matrix given to us was a 1 by 3. It could, depending on the context of the problem. And it's not so much, Joe, that adding rows in the original matrix would change things. But what we haven't seen yet is that matrices can be used to model systems of equations where each row would have a meaning and each column would have a meaning. So if I would go multiplying, in your sense, if adding zeros, you're like, it doesn't mean anything. But as soon as I start multiplying, then all of a sudden I'm putting numbers into rows and into columns that don't belong there. So out of nothing, you're making something, and we'll leave that to God. Sound good? Okay. So kiddos, with multiplication, matrix multiplication. Once again, I don't make you necessarily memorize these. But what I want you to notice is a lot of these are fairly straightforward in the sense of the associative property, the distributive property. But there are some things that you guys might not even realize are missing, bless you, that make a big difference. There are some things that are missing that make a big difference. The one biggest thing that's missing is that A times B does not necessarily, I'm not saying it never can, but it very rarely is. And how does that make a difference? Once upon a time, if we were distributing A times B and A times C, we didn't really care what order it was in. But right now, it is crucial that A stays to the left when you're multiplying, or that C stays to the right when you're multiplying. The order is extremely important because, as you guys just saw, A times B is not the same thing as B times A. This one's legal, that one could be illegal, that one's illegal, that one could be legal. But long story short, even beyond the legal, illegal, their answers will be different because the multiplications, the additions will be in different orders. So therefore, whenever you see matrix multiplication, and whenever you see matrices on the left, matrices on the right, matrices on the right, matrices on the left, that order has to stay the same. We cannot just go switching it around. Make sense? Give me a thumbs up if you're like, yeah, I'm kind of listening. Some of you are still dazed. Hang in there. I know. So who is this guy called the identity matrix? So who is this guy called the identity matrix? Oh, crud. We're supposed to be multiplying it? And they switched it? I thought we couldn't switch them, right? Well, this would be matrix A, this would be I, this would be matrix I, this would be A. A few things to notice, he's a little square matrix, which we knew identity matrices needed to be with the ones and the zeros everywhere else. But what happens, kiddos, when you multiply? First of all, is it legal to multiply a 3 by 3 by a 3 by 3? Yeah, and you end up with a 3 by 3. Okay, ready? You don't even have to show all the work, just work with me. Ready? What do you see? 3 plus, what's 3 plus 0 plus 0? Okay, cross over down. What's 0 minus 2 plus 0? Oh, sorry. 0 minus 2 plus 0. What's 0? Sorry, 0, 0, 5. What do you notice is happening? It's the same thing. The identity is the matrix when multiplied by the square matrix when multiplied by another matrix that will result in itself. Identity, it's the matrix when multiplied by a matrix that doesn't change anything. A times I is A. Does it work both ways? Because 3 plus 0 plus 0, isn't that still just 3? Negative 2 plus 0 plus 0, isn't that still negative 2? And 5 plus 0 plus 0, isn't that 5? Identity matrix is the one matrix such that the order does not matter when you multiply. One of the reasons is because it's square, and one of the reasons is because of the very strategic placement of ones and zeros. So not only is the identity matrix helpful for 1x equals 1y equals 1z equals for RREF and 8.1, but the identity matrix is always, or also, the one such that A times I is the same thing as I times A, which is the same thing as A. And you might be like, well, what on earth is that useful for? Well, it's useful for solving equations. Now, I don't actually need you guys to write down this next page because this next page says, hey, say you're given a system of equations. And you're like, wait, we were given that in section 8.1, right? Can we put that into matrices? And the answer is yes, but what's different when they're augmenting it? Do you guys see the dotted line in this guy? Okay, so maybe they're just showing us a different way of solving a system. And here's the different way of solving the system that actually goes on to the next page. Let me see if actually we can just skip this and go to the next page. Can I skip it? No, that's the word problem homework help. I'll show it here. If you're given a system of equations, and if you basically factor out, which is super weird, I know, but if you take the x1, x2, x3, x1, x2, x3, we can actually pull them out to get variables. We can have the coefficients times the variables equaling the constants. Here's the crazy thing. Whenever we had something before, like 5x equals 10, wouldn't we just divide by 5, no big deal, and x equals 2? right? But if we have a matrix times variables equals constants, do you think it's a thing just to divide by a matrix? Have we learned matrix division? No. So here's what we would do instead. We would say, in order to solve, if we could somehow get this matrix to be the identity by doing something that we're going to call an inverse in the next section, if we can figure out who the inverse is and multiply it on both sides, then we would actually be able to get the identity matrix, and the identity matrix would end up getting us our variables. So there is another way of actually solving systems of equations. But we're going to leave that for section 8.3, which says, hey, how do you do inverses? So we have not learned how to divide matrices because dividing matrices aren't a thing. In math, when there's multiplication, with constants, you divide. But in matrices, when there's multiplication, there's no way of dividing. So we're going to have to learn in section 8.3 what is an inverse and how do we find it and how do we use it. But for tonight and for this weekend, what are you guys doing with matrices? The basic operation, section 8.2 due Monday. Bye, guys.